Hello, everyone. Welcome to the 5G Era Hackathon 2023. Today, we will build some cloud robotics applications using 5G Era software. And you will go through a few exercises and then trying to deliver your own network applications and to offload your task from your local robot to the cloud. And we have a few sessions specified in the agenda. And before we go to the actual contents, Radu, do you mind just to explain the rules for today and agenda for today?
Sure. So first off, I would like to say to the participants that they need to follow some rules when they will reach the step of onboarding. Let me just 1 second, please. So for these steps, you will have to register yourself to the middleware, and you will have to onboard the cloud edge robots, tasks, and so on. What I would like the users to do is for the registration process, when they do the registration, they should provide a role as well. And I would like the users to provide the role user in this field here, in this property. Otherwise, they won't be able to perform the operations that are required. If they don't assign themselves the role as user, they will be assigned the role robot by default, and they won't be able to onboard the edge and the task and whatever they need to do for the hackathon. Also, when they do the onboarding, the whole documentation for all these templates can be found in the middleware docs user and then the onboarding folder where you have all the templates. And also all of this information can be found here and is available for them under this Google Drive. They have everything here that they need for the successful delivery of the tasks from the hackathon. One more thing that I would like the users to adjust when they do the onboarding. Please, when you name your onboarded edge, if you could use your full name here, that would be awesome. So afterwards, we will be able to assess each of the participants' input. Also, for the registration, it would be also nice if they could actually use their own name. So here in the username field, if you could fill this information using your full name, and again, don't forget to register with the role user. Other than that, for the other requirements, with regards to the network application, my colleague Michal will explain to you whatever is needed for you to fill the task. That's it from me. Good luck to everyone. Don't forget you have a quite exciting prize, a 3-year subscription for the VPN WinScribe Pro. Good luck to all of you, and hope to see everyone reach an end for this hackathon. Thank you.
Okay, great. Thank you, Radu. And just, I want to add one important thing is when you finish. So we will have 3 sessions today. When you finish your session, and you should send a message to Radu so he know you finished. And if you can't make it during the process, it's okay. We will do the demonstration at the end, so you know where is the glitch. And in terms of the naming of the edge, and then just to distinguish yourself, so we will be able to see from the server side who is whom. So the rule is very simple. You follow the instruction, and we will show you what is required. And then the instructor just show what are the tasks for you. You do it. When you finish, drop Radu a message. He will know that. And then we will check from the server side. That's the simple rules for today. The winner will get the award. And also for the agenda, let me just share the agenda again. For the agenda today, you already finished your preparation, and we will start our first exercise in the morning, creating a network application for obstacle detection with laser, and then go through the communication examples with the host. And this part will be led by Michał from Brunel University of Technology, and he will give you some challenges, and hopefully you can make them easily at the end. I will pass my mic to Michał, and then you will start from his part.
Hello, everybody. Let me just share my screen. Okay. It should work now. So for today's first part, you should, as I said yesterday, for this part, you should update the application which I was showing you yesterday about moving the robot using the laser scanners. And the task for today is to make the computation of the nearest object based on the laser data on a network application. So if you open the Hackathon repository, I just sent the link to the chat. You can see there is a step-by-step guide which should guide you through the task. Yesterday we went through the first 3 points. For today, I would ask you to pull from that repository, because I made some changes in the README and also in the code from yesterday. So it's a good idea to make it updated. And I will briefly show again the task which you should make. So for the task, you need the TurtleBot simulation. So I will run it, hopefully. Okay, the simulation is running. And as I was showing yesterday, in the Hackathon repository, there is obstacle avoidance ROS node, which if you will run it, it will drive the robot around. So that's the same thing as I was showing you yesterday. And we can take a look on the code. And here you can see that in the code of this node, you are listening to some topic with laser scan messages, and there is some computation which computes the nearest object before the robot, and then you publish this distance, the lowest distance, to some topic, which is later taken by this other node, which drives the robot around. And your task is to move this computation to the network application. As you can see, there is a step-by-step guide in this repository. And there is in the repository, there is ERA 5G network application template, and you should start work with this template. So in the steps, you should rename it, then open the file interface.py, which is inside this package, the file interface.py. And for this session, you should work only with this file, or you should edit only this file. So you should follow the instructions. And after that, you can try that it works by, by running this interface.py file. It will show you something like this. That means that the interface or the network application is running. And to check that it works, you can use the file client.py, which is in the root of the repository. And if you run it, it will send some of the test data, which are located here in the file laserdata.txt. And you can see that it will send the data to network application and it will obtain some results. So that's it for the task for the morning session. And I think you can start.
And what kind of time scale we have? We have we have 1 hour for this session. So if you can finish this part within, let's say, next 15 minutes, then you are good. And for Michal, and are we planning some demonstration at the end just to show what is the expected procedure for completing this task?
Yes, I will prepare the demonstration, and at the end of this session, I will show it.
Good. How long do you need for that bit? 10 minutes?
Yeah, probably something. For the demonstration, I think 5 minutes are enough.
Okay. Let's say we will give the time from now until 11:30 in the UK, 12:30 in the continent for participants to complete your task yourself, and then the final 10 minutes for general question, and Michal will do the demonstration. Thank you very much. Let's go ahead. And when you finish, remember, let Radu know you have been finishing.
And I forgot one more thing. Once you have this network application ready, you should create a Docker image from the network application. You can find some Docker file, some example Docker file in the repository, and you should upload it to the Docker Hub so we can use it later today. There are some credentials. No, they are not. I will send them to the chat.
Mm-hmm.
And if someone is really fast, then there are some bonus tasks. So you can try to read this bonus task and make them as well.
The bonus task will also be counted as part of your contribution. So if you have everyone finish the basic task, we'll see how do you do with the bonus task. Great, perfect. Thank you.
Good luck, everyone.
Hello, welcome back, everyone. In this section, we will do some basic configuration of the 5G era middleware. For this, we have presented you with a few challenges to be made. First one will be to register a new user in the 5G era middleware. Second, we will onboard a new cloud or edge. You can choose which one you want to do. Onboarding process is the same for both of them, so it will not be any issue. Then we will onboard a new robot, and finally we will onboard the network application that we have created beforehand. But let's give ourselves a bit more time with this, and let's start with the onboarding of the user. Under this link that I'll send right now to the chat, you've got the detailed instructions how to do so. And let me know when you will manage to do so. On your virtual machines, you have Postman installed with some basic endpoints. They will work, but they're not the latest, so you will have to change them and to create a new user with the username and password and the role. So as Razu said before, please remember to create a user with role user, and I'll be checking on how are you doing from the database level. And but one thing, I already saw Paul registering 2 users already. Shall we count him as shall we count this task as done for him?
Yeah.
Okay. Okay then. So we'll have this solved, and when you will finish, please report to Radu, and Radu will tell us who finished. Okay. Good luck.
Bartosz and Michał, shall we say we will do the demonstration in 12:30 UK or 1:30 continent? So 50 minutes or 45 minutes for everyone to follow you, and then for the final 10 minutes, I have squeezed both of you to the demonstration. Is that feasible?
To be fair, I would rather have the network application demonstration before we will onboard it, because creating a Docker file is actually necessary for this.
So what time is best for you to start the demo?
I don't know. I think that we should be able to finish onboarding of the user, robot, and the cloud or edge within half an hour. I think it is more than enough time. Even 20 minutes should be enough.
Minutes. So let's say 5 minutes past 1.
Okay.
So that's your time. It will be 5 minutes past 12 from UK.
Yes.
Great. Let's start.
Okay. Just to let you know, I'm sending the onboarding guides to the chat, so you can access them pretty quickly.
Yeah, so the instruction is in the chat, and you will go through the and get the onboarding process completed. I will pause the recording for now, and then we resume the recording when the demonstration is started. You go ahead.
So anyone going ahead with the onboarding of the network application, you can find some utility configuration files in the home directory in the middleware /util folder. To see them, you'll have to pull the latest changes using git pull command. And then you will see the deployment.yaml file and the service.yaml file, which will contain the deployment and the service configuration that will be helpful for you to create the network application onboarding configuration, as you can see in here in this tutorial.
May I ask one question? This might
Go ahead.
be a little bit basic. Why do I need to do the onboarding? Because normally when I have my application, build the container, I just pull, I use my application. So what is the
reason
behind the
why
onboarding?
we are using onboarding? We have to know how to deploy the application and what application does the end user want to deploy using 5G era middleware. So for this, from the network application developers, we require them to create the Kubernetes deployment and the service manifest as they would like the application to be deployed. And then we are incorporating this into our own planning system to have the latest and deployment measures, so we can actually plan the deployment ahead. So the user will just specify, I would like to deploy this network application X, and middleware, thanks to the uploading this configuration that you can see in here, will do the rest automatically for us.
Great, thank you very much. So that's mainly designed for the deployment. Great.
In this way that I'll now present how the onboarding of the user and the registration of the user and onboarding of the cloud or edge will look like, and then I'll pass my microphone to Adrian, and he will showcase the onboarding of the robot. Is that all right? Okay. Have everyone finished, or would you like to have a bit more time to do so?
I've got a little bit caught up with Docker stuff, so I'm yet to finish the onboarding, but it's fine. We can move on without me. I don't mind.
I mean, we still have a time, so we can give you another 10 minutes, let's say.
Yeah, sure. That's fine. Yeah. No
Okay.
worries.
So let's go back to this at 15 past. Okay.
Sure. Sure. Shall we go ahead with the demo to proceed, or shall we keep more time for the hackathon?
So maybe let's go with showcasing how to register a user and onboard the cloud or edge and the robot, and later we'll give the participants a bit more time on how to deploy the network application.
Definitely, you can.
Onboard.
They can. You everyone can do it in the lunch break as well. But Bartosz will demonstrate, so you can follow him.
Okay. So to start, we will start with registering the new user. For this, we'll need the username. Oh, just let me make it slightly bigger. So it will be easier for you to read.
Much better, thank you.
Okay, no worries. So I'll create the arbitrary user with my initials. And as you remember, we have to create a user with role user. Now, when we will send the request, we should have received the our unique identifier that we'll need later on, our username, and the confirmation of the role we are assigned. After this, we can log in either with our ID or username. For the purpose of this tutorial, I'll use the username and the password. And now, as you can see, we've got a unique token that will allow us to access other endpoints in the middleware. So we'll need to copy this. And now we can, this is the whole process of registering a login in to the 5G era middleware. Without this, as you will see, for example, we will not be able to access any endpoint.
You got to replace the URL, Bartosz.
What I'll do, sorry for this. If I can type.
Bartosz, the IP address should be 1064.
Okay. Okay, thank you very much, Aidan. I got it already.
Oh.
So just to have a current value, this I will place the IP address of the middleware in the variables section, so it will be set for every single call that we will make. So now, as you will see, without the token, we've got the 401 unauthorized, and this is the correct behavior. To be able to access this, we'll need to set the authentication to the bearer token and copy the token that we got from the login endpoint. With this saved, we should be able to retrieve the list of the clouds that are registered in the system. So now let's move on to the process of onboarding the new cloud. As we know, we'll have to set the authentication to be the same, the bearer token. We have to make sure that the headers that we'll use will be for the content type application/JSON. And now we'll move on to filling the values to onboard the cloud into the system. So I'll name it with my full name. Organization I will set to 5G era bed. Type, it is not needed, it will be always cloud. Status is online. IP address, let's say for now it will be 217.0.0.1. It is not needed at the moment. The CPU, the property of the CPU is how many CPUs do we have as in a physical CPUs. So let's say that we have 2 CPUs in this cloud and with the total number of 8 cores. So it means that each CPU has 2 cores. Disk storage, let's say this is 100. This value is expressed in the gigabytes. Same with the RAM, which will say that it has 32. And the virtual RAM, also expressed in gigabytes, let's say it has 16. With the MAC address, let's leave it like it is for now. It should be something like CD:AF something. So now we should be ready to onboard it. So let's send a new request, and hopefully everything will work. And as you can see, it has succeeded. We've got the status 200 OK. Our new cloud have been assigned a new unique identifier. So now we should be able to get its value by ID with the bearer token. And as you can see, it has been correctly saved, and we can retrieve it from the database. This is the whole process of onboarding the new items to the 5G RAM middleware. And now I will pass my voice to my colleague Adrian, who will showcase you how to onboard the robot into the middleware, which is a bit more complicated process.
Everyone, I will share my screen now. Okay, so just let me know when you can see the screen and we will continue.
Yeah, it's all good.
Okay, perfect. So for onboarding the robot, we are going to also need the postman. We also need to have a user already registered. So I'm counting, we already have the user for us. So what we are going to use is in the postman, there is already the definition of the onboarding endpoint. So we will go to the 5G middleware, we will go to data, and inside data, we have a robot. And inside the robot folder, we have a post method, which is robot add. Okay. So in the robot add, we have to paste the template that we are going to complete now. And also in the authorization section, we also need to select the beer token, and we will paste the token that we get when we do the login. So please make sure you take the token from here and paste it in the authorization section before we move on. So to complete this template, we first need to have the robot simulation running. So I'm gonna ask everyone to run again the WeBot simulation that we were setting up the other day. So just to remember us, the command you need to run is ROS2 launch WeBot ROS2 TurtleBot robot.launch, and you will get the TurtleBot 3 target simulation run. Okay. I think I'm gonna. Okay. Okay, so in the I'm gonna also send in the tutorials what you need. Okay, robot templates. Okay, robot onboard. Okay, so first of all, I'm gonna send this over the chat. This is the link for the web, not this one, everyone. Okay, so this is the link for the robot template that we have to complete. There are a few fields that we can first complete manually. So let's go through them. First of all, we will just put a name for our robot. So here I'm going to put TurtleBot 3 simulation. I'm going to put 3. Then you have the model name of the robot, which in this case for TurtleBot is the model of burger. So we will put burger. Then status we can put ready. And the battery, let's say it has a 100% battery. And then for the ROS version and the ROS distribution, we are running our simulation of ROS2. So for the ROS version, we would put 2. And for the ROS distribution, you have Foxy. I would like to add that for all of the information regarding the robot, you have a guide which will allow you to put the proper names So capitals are important. So if you put Foxy with the lowercase, it will not work. So please refer to the document in here, so you can onboard the robot properly. As we said before, we are going to use the Foxy distribution. Then we have some other miscellaneous information that if you don't know about, you may leave empty. But for example, for maximum pit load, I'm putting 15. For velocity, I'm putting 1 and 1. For the robot weight, 1 kilo. And then there is some information that's also not required, but ROS repository. I'm putting the.
Sorry to interrupt, Adrian. May I please ask you to zoom in a bit from the view? You have the view tab. Yeah, you have the view tab on the top, please.
View tab.
In the Postman. In the Postman.
Oh, in the Postman.
Yes. View tab. File, edit, view. Top left corner. Yes.
Oh, okay.
View.
Here.
Zoom in a bit, please.
Zoom in. Okay. Okay. Sure. Thank you. So now I see them.
One more time would be perfect. Thanks so much, Adrian. Sorry to interrupt.
That's okay. Thank you, Radu. Okay, so we were in ROS repository. So we will put just the URL if we want. And now the complicated section is actually this one, which is the ROS node. So in the ROS node, it is a very long JSON file, let's say, which is going to include all the nodes that are running in the robot with information regarding to the ROS publications, ROS subscriptions and services, the type and the name of the topics. So obviously this is a very long process if we actually want to do it manually. And this is why we have created some utilities for you to run. So if you have the middleware folder, download it into your virtual machine. You have to go under the utilities folder. And in here you have a script, Python script. In this case, there are two versions. One is the ROS2 and the other one is the ROS1 version. So please, you have to run the ROS2 version, which is this one. So in a terminal, make sure you have the TurtleBot running. And in other terminal, make sure you run the Python script. Also, it is very important for you to source the workspace and the ROS installation. So you will have access to all the ROS topic nodes. And when you run the ROS topic list, you will actually get the data. This script is actually querying the ROS all the time through. It will look through all the nodes and do the query of ROS2 node information and so on, and it will generate a file for you. The file name that you should get after running this. Let me see if I have it. Tutorials, documents, tutorials, onboarding simulator problem. Not here, sorry. Okay, here. Yes, so after you run the script according to the instructions, you will get a new JSON file, which is robot onboarding version1.json. So you take this file and you have to copy the content of the ROS node section into the Postman request. If you have any issues, let me know. And then after you run this script and paste the content in here, there is also some other information that you will have to include. Not all of them are required, like manufacturer, you will leave empty if you want, manufacturer URL, you can leave empty. And then MAC address, you can put just this one that is by default. And then it is important to specify also for the locomotion system, the type of the locomotion system of your robot. So please follow the guide, and in the guide you have the type of locomotion systems that the middleware can check. So you have a locomotion system and locomotion type. So if your robot is differential, hexapodal, and so on, you paste it in there. For the TurtleBot 3, it is a differential drive robot. So we will put differential drive. And then we can put some sensors. For including some sensors, you can paste one of these JSON structures in which you can specify the name of the sensor, the type, and then you have here the type of sensor that we are currently supporting. So for the TurtleBot 3, we will want to specify laser. Then you can put some description, and then the node that is responsible for publishing the sensor data. And also, if you want, you can specify the number of sensors that this robot has. So if the robot has a laser, the TurtleBot 3 only has one laser. So we will put just here one. Okay. And then after you have completed everything, make sure you update the onboarding time and the last updated time. This should be the same values. So you can put the day of today. So it was 26. And after that, you will just send the request. Okay, and you will get automatically generated GUID, which is the unique identification for your onboarded robot. We will be using this automatic ID generated in the next step to actually deploy the network application that we have been doing before. So we will have the onboarding and NetApp application ID and the onboarding robot ID for the next section to be successfully completed. So I'm going to give you a couple of minutes to run the simulation, try to run the onboarding script, and try to get the ROS data and complete this template. And yeah, let me know if you successfully onboard your own robot, and I will be answering any questions you have.
Hello, Adrian. Can you hear me?
Yes.
Is this part a pre-requirement for the afternoon session?
We will need an ID of a robot for the afternoon session, but if the participants have any trouble, we can use any other ID that is already in the Redis database. So it is not a stopping thing, really.
Good. We are slightly behind schedule, I would assume, and because the scheduled time for the session will be finishing in 5 minutes. What do you suggest, and should we allow the
I'm going to
participants?
suggest a couple of things. So first of all, if you are struggling with the time, I'm going to send the link of this template already completed. So in the documentation section of our Git page, we have a TurtleBot simulation template already completed. So if you don't want to go through the process, just copy this JSON template, paste it in the Postman, and you are good to go. You may want to modify the name and so on, but if the template is available for you to skip the whole process if you don't have the time. I mean,
That will be very helpful.
so, yeah.
And then this is the last step we have for the morning session. Am I right?
I think so.
Yes, I think that we'll be
Yes,
only
that's
left with the presentation of the finalizing the NetApp network application from Michal, but I think that will be it for the morning session.
And then you can see on the right-hand side, Adrian already pasted the link. This is the pre-completed template. for TurtleBot 3 and the whiteboard simulation. And that should be sufficient for you to start your afternoon session.
Also, keep in mind, if you onboard the robot, keep this ID with you. So for the afternoon session, we will just paste it in the following exercise.
And also, we should have 5 minutes for Michal to finish the demonstration on the beginning part. And could we do that? Yes. So you can do the onboarding during the lunch break, but now let's have a look what we have from Michal's side.
Okay, I will share my screen. Okay, so for the morning session, the task was to create a network application which will be receiving the laser data and sending the distance to the nearest object. I just opened the steps you should follow. Okay, and you can see that the first thing should be to rename the network application package. So in this case, I rename it to the nearest distance package. The second step was to edit the interface.py, and in this thing, you should edit the register method. So the register method, as you can see, I read the scan width from the ARCS dictionary. You should create a subclass of task handler internal queue, so you can see it like here. It's just as is written, it's just subclass of this class with additional parameter to hold the scan width, and it is used here in the register method. So instead of the original task handler, we use this our own with the new parameter. And after that, you should work with this JSON callback HTTP method. And in it, there is just copy paste the algorithm from the ROS package with updated data, because now we're getting the data from this dictionary. And also we are getting the parameter from the task variable. And that's it. That was the thing you should have done. And after that, you should just use the Docker file. I just update the name of the package, and yeah, that's it.
Thank you very much. Okay, great. So we have the demonstration, and we are reaching the final part of the morning session, and it's time for you to have a break, or so the time you can catch up if you miss any step. I will keep this session open, and you will be able to see all the links they send from the right-hand side in the chat box, and we will resume our session from 2 o'clock in UK, which is 3 o'clock in the continent, to complete the final step. We have prepared everything, then we want to offload the robot application in the afternoon session. And thank you very much. Is there anything you want to add before we have a pause for the session and then to have the lunch break? Take the silence if everything's good. We'll see you in at 2 o'clock. Bye. Hello, everyone. Good afternoon. Welcome back to the final part of the 5G Hackathon 2023. In the afternoon session, we will finish the last step in terms of connecting the robot to the middleware, to the cloud, and offloading the robot tasks. Also, this is the time we will give you the chance to troubleshooting everything you have and make sure you follow us during the process. If you have any difficulties in completing the task, we are here to help you. For the afternoon session, we will be started on the consuming the newly created network application by robots. And this will be led by Adrian, and Adrian from our side will give you a quick guide on how to proceed, and then you will following the task given by Adrian to complete the full hackathon for the afternoon session. And if you already created your network application, you can use it now, and otherwise you can use the application shared by them, and then you can still resume follow us during the process. This is pretty much a quick talk. Radu, do you want to add anything for this bit?
Not really, but just that I've seen so far, I've seen Marek and Paul will have some entries in our database. So I guess it's the contest is between them.
So the competition
so far,
is between them.
So far, yes, at least what I can see. Regarding the network applications, I guess Michal will be the best to assess what they have done. But in terms of onboarding and interacting with the middleware, I can see Paul and Marek that have actually
leading.
Yes.
We also have our own input, but they should not be counted.
Yes, we do have other input as well, but yeah, as you said, this will not be a part of the hackathon.
Yeah, we will decide who is the winner. Is the final session after this part is completed. Good.
Sorry, can I just ask quickly? I think I did things the wrong way around. I put in my network application before the cloud and the robot were onboarded. So I don't know if I should go back and onboard my network application again now with that that having been done. Possibly, I'm not sure.
Oh no, it isn't a problem. The order for this is not important.
Yeah.
Okay, perfect.
So they will both be saved in the database as long as they are available. The middleware will orchestrate them. Doesn't matter the sequence.
Exactly.
By the way, I do remember Adrian showed us that the time would be set over there. What do we do with the time? It's not currently in use, just for the sake of recording the the submission, the speed.
Yeah, it's only for recording and showing it in the dashboard, not really being used for anything else.
Okay, great. And yeah, Adrian, do you mind? You can start a little bit earlier than scheduled, but it's good to give other people more time to do the last bit of the project.
Sure.
This is recorded, as I said, and then we will share them online in the future. Please go ahead.
Okay. So for the final step, we are going to deploy the network application we have been onboarding this morning. For doing that, we are going to use a Python script that you can find in the middleware folder that you have downloaded. So in the middleware folder, please go to SRC, and inside SRC, find Python interface standalone. And inside it, just double click on the script. In the script, there are a few things that we need to change for this to work. So first of all, we will have to include our onboarded username. We will also need the task ID and we will also need our robot ID. So in line 9, you are going to put the username you have been onboarded when you did your registration. So use the GUID that you have previously used during the login process and pasted it in your script. Following, you have to put the task ID of the onboarded task. So I will show you here. I have the endpoint for onboarding a task, and I get, after the submission of the template, I get back an ID. You will paste this one in here, in the task ID. And finally, you have to put in the get plan section under line 51, you will paste the robot ID that you have previously on board. And with that, you are set to launch the script. After you launch the script, you will get your new NetApps deployed. So please, you can use the command I have.
Hey, John, sorry to interrupt you. Do you mind sharing the GUID identifier of the task and the robot with everyone?
Oh, yes, of course. The one that they need to use right now?
Yes, so basically everyone who did not deploy their own network application or struggled with some other part can follow us in this step.
Yes, unfortunately, I don't know if I can copy them into the chat. Yeah.
One suggestion: do you have Redis Insight open, or at least because you are in the VM, right?
Yes, I'm gonna send them to.
No, no, don't worry. I will just show me the IDs and I will paste them in the chat.
I will paste them to you in the Slack, okay? And you can paste them, okay?
Okay.
So robot ID.
Okay, all set, Adrian.
We are missing still. Oh, you got them?
Mm-hmm.
Okay, Adrian, just to let you know, you have stopped sharing your screen.
Yes, I will be sharing the screen back in 1 second. Task ID, robot ID, and I'm gonna also set the username. Okay, if you can paste those three in the chat, that would be great.
Yep. You carry on.
Okay. So we paste those three, and now you can use the kubectl command to verify the deployment. So do what -c kubectl get all -n middleware, and you should get the pod and the services created. So here I have Nginx. I'm going to try to deploy now the new one that we have created for LaserScan. And you should have the pod and the service. So now I'm going to use my one. So this is network application. Okay. Okay, I'm getting one error.
Asian, do you mind checking in the postman what is going on? Because for me, it looks like there is some misconfiguration of the task.
Yes, so first of all, I have the task ID right here. So I should paste it that one here, I guess. And then for the username, I have included this one, which is working. Yes.
Okay, so we know that this thing is solved.
The robot. I just onboarded this one. Which I pasted in here. Let me try one. Okay, now it's working. So I'm gonna do what's I think I opened something else. Okay, I have created a NetApp which has name Paul Backason NetApp 85 something. So the NetApp is here.
I must have
But
typoed with Hackathon instead of Hackathon, but yeah, that looks
I
like
am deploying NetApp that is not mine, I think. Yes, what?
Yes, actually, I can confirm that from this identifier, this is looks like it is Paul's network application. So good job, Paul.
I think I might have hadn't changed the GUID from the one that was in the template, so I might have overridden what was there before.
Oh,
If it was the
okay.
same, that's possibly the problem. Sorry.
Yeah, okay, don't worry.
Apologies.
At least we know that the NetApp that you have configured is working. So good job on this.
Sorry about that.
That's okay, no problem.
That's okay. Yeah, as you can see, there are slight improvements to be made on our side when it comes to importing the whole task configuration. but the process is a bit complicated, so we need a bit more time to do so. And okay, Adrian, quick question. Are there any other ways to deploy the network application except of your script?
We are currently working on the action server implementation.
Mm-hmm.
It will be available for you really soon, and we will be able to use it. So I just did those two topic lists, and you can see we have nearest obstacle topic created, which is from the container. So if I try to echo, I would probably get nothing because simulation is not running. Nearest. So I'm gonna echo this one empty. So let me see if I can run the simulation, and it should be getting some data, hopefully.
Okay, that's great. But as I understand, your script and the action server are ROS-based. Is there any other way that we could deploy these network applications without having the ROS embedded in the scripts?
I believe you should be able to do it from the Postman directly. So you can call the corresponding endpoint of get a task deployed, and you will be good to go. This is what we are actually doing inside here. We are calling the plan endpoint. So instead of doing from the script, we can actually do it from the interface.
Okay, can you show this endpoint in the Postman in a bit more detail so everyone will know what's going on in there?
Let's see, the plan.
It should be /task/plan.
Okay, and it's not in data, it is in task. Should be task, this one. Yes. So over here is the endpoint. We have the task ID and the robot ID, and these parameters are actually need to be set like this always. And with that, it will be doing the same thing that we are replicating in here. There's nothing particularly fancy. You also need to put the token from the login, so you will be able to get authorized to deploy the net application.
Okay, many thanks, Adrian.
I'm going to try to launch the simulation. Please give me a second. Okay. After this one.
Okay, Adrian, do you mind explaining out loud what you're doing at the moment so we can all follow this process?
Yes, so currently we have deployed the network application from PAO, and this network application is currently not creating any data in the topic that is the nearest obstacle, because the robot is not running, and the simulation is not providing the laser scan data to the network application, meaning the calculations are not providing any result back. So the moment we launch the simulation, if we echo the topic of the nearest obstacle, we should see some result. Okay, I will also. Okay, in a few seconds, we should be able to get something after the simulation starts running. Any questions so far at the moment? Or do we have something in the chat? Maybe we need to redeploy everything. So it is actually starting from the beginning.
Yeah, sorry guys, that could have been an issue on my part as well. I was waiting to ask a question actually, but I wasn't entirely sure where we were supposed to attach the Docker image that's been generated, so that might be the issue. If that's part of the import task async, I assume, but I just wasn't sure where it was supposed to go. So I was waiting to ask a question at some point. But that may be why nearest obstacle is not coming up.
Okay, do we have maybe other network application to try? Also, I can try.
Adrian, just to confirm to you, as far as I understand, the network application works without any ROS. So no topics should be visible in here. Michal, correct me if I'm wrong, please.
Yeah, you are right. Adrian, you probably have the note from the how to say the original note from the hackathon, the one which was used for the demo. Yeah, this obstacle avoidance node is producing this topic. And actually, it should be the last task for the participants to update this ROS node to use the network application, because in its original form, it gets the detection of the obstacles, and it drives the robot. And for the last task, the participants should change this and offload the computation to the network application. Yeah, this is the solution.
But if I am correct, the network application should accept the connection.
Yeah, it's trying to connect to localhost, but you have the network application on the Kubernetes at the moment, so you would need to change the address. Maybe I can share my screen and show it.
Oh yes, oh, please go ahead.
Okay. So just a second. Okay, for the last part, you should go to this consuming the newly created network application by robots section, and there is a step-by-step of how to update this detector node, this obstacle avoidance ROS node. It is the file where you take the algorithm for the obstacle detection, and you should remove the algorithm, and you should create a client of our Python client library, and you should call the necessary functions to communicate with the network application. There is a guide how to do it, and besides, there are two scripts in the repository. It's called client.py. You were using it before, and you can see that the creation of the client is just importing some classes, creating an instance, and calling some functions. So basically, you need to put this inside the node, and with this approach, you need to run the network application by yourself, but you can also use the client underscore middleware.py, which actually is using the middleware, and it uses a different version of client, which can connect to middleware. So you need to provide it the middleware address, the user, and the password, the user ID in this case. And then you can run actually the task. So you need to provide the task ID, the robot ID, and the necessary parameters. And after that, you can send the data. So I can, hopefully, I can show it here if I find the correct terminal. So yeah, I will run this client middleware script, and you can see that it gets connected to the middleware. It started to deploying the Hackathon K code. It created the necessary service, and at the moment it's waiting until this is ready. So it's similar to what Adrian showed before, but this time with the client library. And you can see that after the client was successfully connected to the network application, it started to sending data and receiving the results. And after that, it just killed the network application. So you can use this client underscore middleware as an example of how to connect the robot to the middleware to deploy the network application and to connect to it after that.
Sounds great. Thank you very much, Michal, for this presentation. And okay, so shall we get back to do some coding again? Okay, so let's maybe give it. I don't know, how do you guys think? How much time you will need? Like half an hour to get this script finished and wrapped up, so we can see if we'll be able to consume the network application from our script.
Okay. And just one thing, I will share with you the
Oh yes, if you could please share the task ID with everyone, that would be great.
Yeah. It's task ID of network application, which is onboarded in the middleware, so you can use it for your test.
Okay. And please remember to use your own credentials for the middleware user and the middleware password, as those will be needed as well. And I believe that the robot that we have sent beforehand will be more than enough to have it as a parameter. Okay, so good luck, everyone.
It's great. This is hand-down time. What is expected to be the ending time for us to close this part? How long should we give to everyone on completing this task?
I think 30 minutes.
30 minutes would be good. So 3 o'clock, we will see. 3 o'clock UK, 4 o'clock continent, we will see. And then instructions here.
Yeah, and one more thing. I just realized you need to pull the latest changes from the hackathon, because I found an error in this client middleware script. But with the latest version, it should work for you. So I suggest you to try the script beforehand to make sure that everything works for you. And after that, you can implement it inside the detector node to actually work from the ROS to the network application.
Great, perfect. So I'll stop recording. I will pause the recording now, and we'll resume recording later.
Okay, I will share my screen again. So for the last part, the task was to update the detector node to actually communicate with the middleware and to well, with the middleware or at least with the NetApp. I have in this example, I only communicate with the NetApp, not with the middleware, but it's just a small change. So the first thing was to create a client of the network application. So you could just use the information from the client script, which was here, and you just created the instance of the object, connect to the network application or to the middleware, and deploy the network application. It will be the same. And after that, in the listener callback, I've removed the core algorithm, and I put there this send.json HTTP method, which was sending the data to the network application. And I created this callback, which was obtaining the results from the network application and republishing it as a ROS message for the other node. So this was it. And yeah, that's all from my side.
And then that's the guidance for them. I think finally, and we have to announce a winner for the hackathon today. Radu, who is the winner so far?
Well, so far we have Paul, Marek, and Yuji that have been going through the steps of the hackathon. Marek, I'm not sure if he was able to deploy the network application. I know Paul was able to do it.
So,
Yes, but connecting the robots to the network application, I guess I would have to ask for Michal to help me out on assessing this part, because honestly, I don't feel confident to assess this part from the users. So if Marek and Paul can send, let's say, a draft of what they did in order to complete this task, and then Michal can send back to me which of the participants had done the correct thing, then I guess we can decide who is the winner between Marek and Paul, because Yuji has not completed this step. He did onboarding and other tasks from the hackathon, but not this part with deploying the NetApp and connecting the NetApp to the robot.
to update this complicated process.
So yes,
we will send email to notify the winner.
yes.
So after the event, and then we will arrange the award for you if you are actually winning the process. And that's pretty much everything for us to do the hackathon today. Thank you very much for everyone participating in the event. It gave us lots of experience and also helping us to go through the process. And stop recording by now.